started recording?
Okay.
Yeah.
Yeah,
All
yeah,
right.
we can see it. Yes.
Okay. Great.
Assalamu alaikum, everyone. Thank you for your time today joining us in this session where we will introduce you to Kubernetes and AKS. Today, inshallah, we will be hosting Abuhijleh, right?
Yes.
He's. I will let him, introduce himself in a couple of minutes. I will not say anything about Ala. He's the expert. So we would like to thank Ala for his time today, providing this session, and for sure for Microsoft to facilitate the whole session also through Teams. So Ala, basically the mic is yours. Go ahead. Thank you.
Thank you, Tariq. Guys, you can hear me clearly, right? I hope so.
Yes,
Perfect.
clear.
My name is Ala Yassin. I'm a senior consultant working at Microsoft as part of the Cloud Culture and the Transformation team. We're working basically on moving customers to the next, I would say, next grade of technologies similar to Kubernetes and the cloud, and adopting new practices around the DevOps, microservices, and all of that. And of course, microservices and Kubernetes are playing a big role in this new era of technology. And I believe, as we're discussing on the WhatsApp group, is that Kubernetes might be one of the hottest topics that is discussed heavily around in the technology community. Good. So without further ado, I will share my screen and we'll proceed. One note, I might not be following on the chat for the questions. So I hope, Tariq, you would be helping me with that in case there are some
Sure.
questions. So yeah, let's start. All right. Can you see my screen? Or
Yes, we
perfect.
can see it.
Okay. So this session, guys, is we're going to give you an introduction to Kubernetes and Azure Kubernetes services. Of course, it's it's a huge topic. There is so much to be discussed in this, but this would be just an introduction, and hopefully, if it gets some traction from your side, we might decide to go with further sessions. So here is our agenda for today. We'll start with an introduction, then we will cover different, we will get into the architecture of the Kubernetes component. What are the main components? Then what are the different objects or resources that you can put together to create your microservices system? And finally, we will see how Azure Kubernetes services will provide you with Bootstrap and the complete ecosystem that will help you to start your cluster and your microservices very quickly and avail a lot of advanced technologies and features. So in the introduction, we will cover the challenges that we face in managing the containerized application. And I hope that most of you has already attended the previous session that was done by my colleague Tariq about containerization and containerized applications. So that we can, because this is a build up on what we have achieved in the previous session. If not, I hope at least you have a minimum understanding of the container technology and how it works, because we're not going to touch into this. We will speak about the challenges that emerged as we started to work on containerized applications. Then we will introduce Kubernetes and some of the core concepts that Kubernetes was built on. And finally, we will look into how you can deploy your first Kubernetes cluster. Of course, after each and every session, I tried my best to make things as light as possible, so I won't be speaking much about the theory, and I'll try to spend more time on the demo side. So if you work on containerized applications, or you are following some of the discussions, we believe containerized applications has provided a lot of advantages to the way we conduct our work. Nevertheless, it came also with its own challenges. So in microservices application, when you end up having a huge number of services, establishing the connectivity and discovering the different services and connect to them become a challenging experience. The other thing is that maintaining, like having a persistent storage that will ensure that your data is there and won't be lost, even if your containers were restarted, or they were dead and you have to start them again. Every time, if you even manage to do this and to link your containers to a persistent storage, every time you start your container, you need to do some work to attach the storage again. Of course, the scalability and being able to scale up and scale down your microservices depending on the need. Challenges in rolling out new versions of the different services and in rolling back in case of you're having issues. Also, we're talking about handling failed containers and have an auto healing system that if a container, you for a certain service, you intend to have 5 containers to serve the traffic or the load, and one of them went out, you need still to monitor this and to bring this back again. And this experience, if you worked in a containerized application without having some ecosystem or orchestration and automation around that, believe me, that is really a nightmare. And from my experience, I saw some organizations decided to drop the whole idea of going with microservices because they think that it is not scalable. It is very hard to manage. And Kubernetes, basically, it came to solve this issue. And Kubernetes started as an internal project within Google. Then it became an open source solution, and they made it available for the public. So what is Kubernetes basically? Kubernetes, it's an open source system that will help you automate the deployment, the scaling, and the management of containerized applications. So you have different components, different containers. You would like to automate the process of upgrading them, installing, scaling them up, scaling them down. Kubernetes will help you to do this. In addition to a lot of the automation work or automation activities. So one of the funny things we see a lot, and I think you guys send in the group, that it has been released less than 10 years, and people are asking for more than 15 years of experience of Kubernetes. If I would like to give them the benefit of the doubt, most probably they want to hire someone who's already was working in Google in the early days of Kubernetes, even before it was called Kubernetes. So there maybe they're targeting people who has established this while it was a Google project. So what Kubernetes do is that it groups different containers that make up your application into logical units. And these logical units, their management and their discovery is managed by the Kubernetes cluster. And as we will see as we move, this logical unit is called pod. Okay. From a meaning perspective, Kubernetes, I think it's a Greek word and it means the captain. And you will see that sometimes we use the K8S, and this means like between the K in Kubernetes and the S at the end, there are 8 letters. So we use this as an abbreviation. So in a nutshell, what Kubernetes is trying to do is to give you a production-grade container orchestration. So you can have a production workloads that you can manage, you can maintain, you can orchestrate, and it provides you with the ability to do that and takes a lot of the daunting and laborious activities. Before we dig deeper and speak in more details about Kubernetes, I would like to discuss with you a few concepts that Kubernetes is built on top of. And the first one is what we call declarative configuration. And the declarative configuration is a way of setting up your infrastructure or environment where basically you don't you just declare the desired state. You just say, okay, you know, from this container, I would like to have 3 instances. You don't have to do the other side, which we call imperative configuration, where you say, okay, deploy 1 container in server 1 and container 2 in server number 2. Give it, you go and do the configurations yourself. What you do in the declarative configuration is that you delegate the work to an orchestration system, such as the Kubernetes. You just create what we call a manifest, where you describe and declare what is the desired state that you would like to have. And the good thing about that is usually the system will compare the current state to the desired state, and it will take the necessary actions to make sure that it matches your requirements. So this is important also, and it will help when you're doing like upgrades to the system, you're introducing new versions. You don't have to do the work in different nodes. You just declare what is the new status, how it should look like, and the rest is taken care by the system. This is a trend, by the way, and you might already have heard of Puppet, Chef, Kubernetes, and also in Azure, we have the ARM templates. You basically describe the infrastructure or the resources, and the engine or the system will take care of that. Another important concepts also that Kubernetes rely on is the idea of immutable infrastructure. And immutable infrastructure means that basically when you would like to make any modification to your infrastructure, you're not going to connect to the servers and start, or the infrastructure component, and start making the changes. Like you open configuration files, or you open databases, or you open whatever configurations file are there, and start making the changes. That is called mutable infrastructure, which means people can make changes to them. The concept of immutable infrastructure is different. It says if you would like to update the configuration of a certain component, you basically declare the new configuration that you build from a common script and image, and you add the changes that you want. You just discard the previous version of the infrastructure component, and as you run the script or the image, you will have a newer version that has the new configurations. One of the things you might hear people talk about this concept is what we call bits versus kettles. So if you have a pet and it gets sick, you will take it to the veteran. You say, okay, you take care of it. And that's how we used to deal with the infrastructure. If a certain server is not working or virtual machine, we used to log into that machine, start looking at the logs, finding out what's going wrong, and start adjusting the configuration. That's the immutable infrastructure. It deals with the infrastructure component as cattles. Cattles means like when you herd cattles and one of the cows or the sheep is sick, you just kill it and you let the cattle breed more sheep for you. So you don't worry much about one cow. You just shoot that cow and you move forward. And that's the concept that we use in the immutable infrastructure, and this is used in Kubernetes. So if you would like to link the dots together, so Kubernetes uses the manifest to declare the cluster components. So it's a declarative configuration. You just write a YAML file, you describe the component you want, and you pass this to Kubernetes, and Kubernetes will take care of this. In some examples, when you try to make, even to make some changes to some of the components, Kubernetes will refuse to let you do that, and you have to basically kill the previous version and recreate the newer version from scratch. Good. So now we know what is the concept of Kubernetes and what are the main principles that are used to and that the community and people who worked on it took in mind. Now we will dig deeper to see what are the different components that makes any Kubernetes cluster. So this is a simplified representation of what a cluster look like. And we all know that when we speak about a cluster, it means we have at least 2 nodes or 2 or more nodes that should work together to achieve a certain functionality. And in Kubernetes, basically we have the nodes, which a set of virtual machines, and these nodes basically will host the pods. And we said that pods are the logical units that includes the containers that will be executed and provide you with the desired functionality. As you can see, each and every node has what is called a kubelet and a kube proxy. A kubelet is basically an agent that will do the work and make sure that this node is connected and it receives the orders that are coming from the master node and ensures that the work is taking place as required. The second component which is the node master or the control plane, and basically it manages the nodes and it is responsible of orchestrating the work, deploying the pods, making sure that everything is working as expected. So we speak about the internal components. So we spoke about the kubelets. Basically, they run on each node and they make sure that containers are basically running and the pods are working. We have the kube proxy, which is basically responsible of the connectivity and what we call the service. It's about the service, the IP address, the networking, the connectivity with the pods, the traffic, all of that happens through the kube proxy. On the master component side, we have the kube API server. And this is the component that is responsible where you basically, as an admin, you interact with, you give the command, And the API server is basically will transfer your commands into actually HTTP requests that will go to the different, that will basically go to the different components or the different, different components of the cluster, and the work will be executed according to these requests. We'll see more details as we proceed. We have the etcd. If you are familiar with Linux, so basically this is a simple way to store data. It's a key value database where you can store data, and basically all the data that is maintained by the cluster is saved in this etcd. Of course, these are the data. This data is the data used by the Kubernetes cluster to deploy, to orchestrate the work. It's not the data of your application. That's something else. I just want to make sure that we don't confuse, like this is the where you can store the data of your application. No, this is the database used by Kubernetes to persist the data it needs to manage the cluster. We have the kube scheduler. Basically, the way Kubernetes works is that when you interact with the API server, you provide your declarative configuration, right? You provide the manifest and you say, okay, this is what I want to achieve. I want a pod. I want the 3 versions of that pod. I wanted to use this amount of memory. And of course, we will come to this into more details. And this will go to the kube scheduler that will basically receive your request and assess the situation on the different nodes and will decide where it should deploy your request to which node depends on the status of the different nodes and what you have requested in your declaration. And the final 2 components that we have are the controllers. Basically, we have kube controllers. They are different controllers that will help you basically do the replication, do the authentication. If you have a request that is coming and you would like to alter this request before you pass it to the scheduler for any reason, you would use the controllers. And also we have the cloud controllers that will interact with the cloud provider and ensure that your cluster is integrated with the cloud. And as we can see, as we proceed, that this is an integral part of Kubernetes, and that's why we always say it is very preferable to have your cluster on the cloud, because a lot of the configuration or the heavy weightlifting is also to configure the cluster. All of that can go to the cloud, and you can build on the capabilities of the cloud. You can build on the storage. You can build on the load balancing, and so on. Okay, sounds good. All right. So so we mentioned that you need to have at least 2 nodes, maybe 2 VMs, one to have the master, one to have one node. What if you would like to have 2-3 nodes and you would like to have a master? Of course, you need to have a master actually. So how you could do that? Apparently, if you would like to go with a production grade implementation, you cannot deploy this on your desktop or laptop to experiment. That's why we have some solutions, and I will be using one of them for illustrations. There is a solution called Minikube. This is something you can easily install on your machine, and you can interact with it as a Kubernetes cluster. You can still practice, you can still learn, but if you started to think about advanced features that are production kind of activities, it might be hard to achieve this in Minikube. So this is only would be for learning purposes. Minikube is also, if you don't want, if you have Docker desktop installed, it comes as part of it, and you can still use that. You don't have to install Minikube if you have already Docker desktop. And in the demo, I'll quickly show you how we do this and how to configure it. If assuming that you're now a master, you're ready to go with your production workloads, and you would like to have a reliable infrastructure to do that, you need to go to the cloud, and Azure Kubernetes services is one of the preferred solutions for production workload. And at the end, I will show you why we believe this based on the features that are already it provides. All right. Two important concepts that are core to Kubernetes are namespaces and context. You can think of a namespace as a way to organize your object in a cluster. So sometimes maybe you can, in the same cluster, you might run different applications, and you would like each one of them to be in a separate namespace. And we use namespaces basically to do the logical separation and later to provide the role-based access. So you can, using namespaces, you can say Ala would have access to the namespace that is called, web site, that includes all the services used for the website. And if I try to access another namespace that hosts, the HR system internal, I won't be able to do that. So I would have only access to the namespace. Okay. So yeah, it could be a folder, or it holds a set of objects that are usually related. Now, one of the things that you might face as you start working in Kubernetes, when you start interacting with the kubectl command line, and as we see, if you give it any command, even if you don't define a namespace, you will find out that it works. And I have to say, when I started learning, that was very tricky to me, because if you don't provide a namespace, there is by default a default namespace, and it will directly, whatever manifests or whatever commands you give, it will automatically deploy this to the default namespace unless you define otherwise. So now, how would you define otherwise? So one of the options that whenever you do any command, you just need to say, okay, I would like to deploy a pod. This is the manifest file, maybe, and you might say, okay, do this in this namespace. You pass a namespace as an argument. Nevertheless, this is not very practical, so that's why we have the concept of the context. And the other thing that the context is important for, as we'll see, is that the context, you might be managing multiple clusters from the same kubectl, from the same command line tool, and you would like to keep jumping between one cluster and another. It's very simple. You only need to say, okay, I just would like to change the context. And the context has three parts. It includes what is the cluster name, what is the default namespace, and which user you are using to do the different activities. Okay? Perfect. So far, so much theory. I know you guys might have already started kind of sleeping, but at least that is important, so that we get into to get our hands dirty. So please don't give up on the too much theory, and stay tuned. We're reaching there. Labels, and in Kubernetes, we heavily rely on labels to identify different objects. And you will see that how Kubernetes is very dynamic in a way that you connect the different components to each other or the different resources to each other by relying on labels. So you can connect different services to different pods in so many different ways just by playing around with the labels. So it's a way to identify and reach different objects, and it's fundamental. All right. So now we will start talking about coding and the comments, which is something I like, and I hope you do as well. So in Kubernetes, everything is represented by a RESTful resource, which means actually what happens is each object will have its own unique HTTP path that will lead you to the representation of that document to that object. And this is just an example. So your Kubernetes cluster URL, then you have API version 1, then the namespace, then the name of the namespace, then the pod, and the name of the pod. This is how I will reach to a pod called my pod that is deployed in the default workspace. If I have another workspace that is called web, and I have a pod there that is called my pod, if I would like to browse to that to the representation of that object, so it would be namespace / web / pods / my pod. And this is, if you're familiar with APIs, and this is very common now in the way that we represent objects and the ID of the object. We see this as well in Azure. You know, the subscription, then the subscription ID, then the resource group ID, etc. So how you're going to interact with the different components, you need to interact with a kubectl command line, and it will make basically the required HTTP requests on your behalf to do the required job. What are the different commands that you can give to the kubectl? kubectl get, resource name, and the object name. So far, I mentioned resource name or resource or object, and we still did not mention what are the different resources and what are the different objects. And that just to make sure that you stay hooked and you will keep saying like, what are the resources? So that is intended. So if you would like to know to get the list of objects of resources, you would just say kubectl get pods. It will get you the list of all pods. If you provide also the pod name, then it will only show you the information about that pod. Okay. kubectl describe is similar to get. Nevertheless, it will give you more details about a certain object. kubectl delete is going to basically delete that that resource. Of course, kubectl edit, and that's a very handy way if you had something deployed and you would like to make changes to it. You're not going to get into the pod, or you would like not to get into the nodes and start to make changes. You just open the declaration file by doing kubectl edit. You updated it. Once you close it, the cluster will automatically schedule and consume the new changes. kubectl apply -f manifest file. If you have a manifest file and you would just like to deploy it to apply the changes, and we use the apply if we are having the manifest for the first time, or even if we making changes. All right, let's have a demo.
Finally, demo.
Ah, you're waiting for that. Okay.
Yes.
Okay, let me just. All right. So the first thing is basically we will show you how to run the cluster and how to do this in this on Docker desktop. It's very easy and very straightforward. There is nothing much to worry about there. I just need to switch to the other screen. Or let me just open the configuration. Yeah, I think I have to switch to the other screen. Yeah, can you see my screen? The other one?
Yes, we can see.
Okay, so if you have Docker desktop, if it's working and you need to make sure it's working, you will find out this whale here. Right click. You can see here, there is Kubernetes. Okay, and these are the different contexts that I have already defined. To enable it, you need to go to settings. And you will find here Kubernetes. All you need to do is just to say enable Kubernetes. That's it. And you will have a Kubernetes cluster that you can easily interact with and start your working with. This is the easiest way to get you started with Kubernetes. Okay. Now, once you enable this, automatically you will have a kubectl command line that you can interact with. All right. So I'll switch back to the other screen. All right, and let's see what you are going to achieve. Yeah. Okay. So the first thing I will do is that if you remember, we said for any kind of object, if I would like to get the list, I will just say kubectl. So everything will start with kubectl, and then I will have yeah.
If you allow me, if you can just increase the font.
Okay.
If you can. Okay, good, great.
Yeah. Okay. Yeah, it's clear now.
Yeah,
Okay.
for me it's fine. Yeah.
kubectl. Then I would say get nodes. So this will see, it will tell me, look, you have one node that is named Docker desktop. It's ready. The role of this node is master. It has been created 14 days, and this is the version of Kubernetes that is running on it. Now I don't have what we call worker nodes, because this is just a small implementation that I am using here. Now if I would like to get the namespaces, I would just do the same. I would say kubectl get namespaces. All right. So you might have noticed that I used an S. I did not say namespace. And this is one of the things in Kubernetes. When for each and every object, there is an abbreviation. So you can either use the abbreviation or you can use the full name. So how you would know what is the abbreviation is, you would say kubectl API resources. So can you see, these are all the different resources I used to talk about, right? I was saying if you would like to see a resource and the resource name. So these are the different resources that you can deploy or you can deal with in your cluster, all right? And this is the short name. So see, namespace, the short name is namespace, all right? And this is the kind. The kind is what you use to basically to define when you create the manifest, and we will see that as we go. Okay? And good. So these are the different names. Here you will find out something called API group. You will find out that some don't have an API group, while other they do have an API group. And in each and every manifest file, you need to say at the beginning, you need to declare to say, okay, I'm using, this is the kind of the resource I'm creating, and it's part of this resource group. Because you might have different API groups, and this is a very good feature in Kubernetes. It's an advanced feature where you can even extend and introduce your own resources and resource types. So you will come up with your own API groups. I won't touch on this because this is an advanced topic. So let's go back and try to create a namespace. So I would say kubectl create namespace. Okay, and the namespace is, I will call it NS demo. Okay, so the namespace is created. Now, if I do kubectl get namespaces, see, it was added. Now, if I did any action, if I try to create a pod, it will not create that pod basically in the in the namespace that I've just created. Because what is the default context? The default context would be the default namespace. So how can I see what are the different contexts I have? I would go to kubectl config get contexts. See? So I have this asterisk. It means I'm on the it's the context is called Docker desktop. The cluster it is running on the Docker desktop. This is the authentication info, and there is no namespace. So then it will always run on the for the default. Good. So let's assume I would like to create a new, so that I don't have every time to create a so to add the namespace. So I will create a config, sorry, a context. So I would say kube ctl config set context. I will call it KS demo 2 because we have already one. I would say cluster. This is the target cluster, Docker-desktop, and the user is Docker desktop, and the namespace is NS demo. See, the context is created. If I say kubectl get contexts, can you see it?
Yes.
Okay. Now it was created, but I did not move to that. So I would say if I would like to switch to it, kubectl config use context k8s-demo2. I made a mistake with the name.
There is no S.
KS2.
Sorry?
It is K82.
Sorry. Okay. So I would get context. So now everything I do, it will automatically work in this context. Any questions? Interesting? All right. So let's move to our next topic. So now we defined a namespace. We have defined our context. Let's see what else we can do. Let's go to pods. So we will quickly discuss what are pods, what is the pod manifest, and we will jump into the demo. So what is the pod? The pod is actually the execution unit of your Kubernetes application. It's the smallest and the simplest unit that you can create and deploy. So if you start working, you will just work on pods. But as we see, when we go to the production and we will speak about deployments that basically will manage the deployment of the pods. So what is in the pod? So, and there is a lot of confusion usually when we speak about the pods, where they say how this is different from a container. All right. So basically, a container is just the Docker image that has the code encapsulated inside it. But the pod goes beyond that. There are some times where you would like to deploy multiple containers together. So they're doing some shared functionality. There is a design pattern that we call a sidecar, where there is one part of one container will basically retrieve the data from the internet or from a GitHub or from a centralized server, and there is another another container that will consume these resources. You don't want to confuse to mix the functionalities of both, so you make them both live in one container, also in one pod. The good thing about the pod is that also it includes the storage resources. It includes the details of how you would like to manage the different containers. What are the required resources and the limits that you would like to put for each and every container? So by that, if your pod was down and then the Kubernetes identified that and it brought it up, it will automatically attach whatever storage you have defined and whatever governance you have put in place in creating that pod, it will be in place. Okay, so of course, I think we've touched on this, that one important part is in the pod is to have persistent volume, because anytime the pod is killed or it dies, basically all the files that lives inside the containers will die. If you would like to have a persistent data, you need to use volumes and include them in your pod. So this is the manifest of the pod. If you look at the top, you will see at the metadata that, at the initiation of the declaration, what is the version, what is the kind of the object, and I think we've covered this. Then we will move to the metadata. What is the name of this pod? In which namespace it should live? Then we basically define what are the different containers that lives inside this pod. So as you can see that containers is basically an array. You can include multiple containers. And finally, if you're connecting to a private container registry, you need to have a secret. And I believe my colleague Tariq has already covered how to manage this and how to go all the talking about the registries. Okay, so here the container, you can define multiple objects or multiple attributes. What is the image details, where you're going to get the image from, what is the source of the image, if you have any volume mounted, and this is, you would say, okay, in this container, I would like to mount this volume, and this is the name. What resources you're requesting for this container, and this will be used, if you remember when we spoke about the scheduler, it will decide on which node it should deploy your pod. So it will basically gather the information about how much resources you're requesting and look at which node is the most suitable one to host this. And we have the probing, and this is a very interesting thing that is built in Kubernetes, where the system is an auto healing, and we will see as we go, which means if the Kubernetes will keep probing the container on this liveness probe, and if it did not receive response, it will assume that this pod is not live, and it will reconstruct it again. And finally, the boards and the information details. Okay, so I will go. Yeah.
If you allow me, just one question.
Sure.
Let's assume that we have an application which contains of three tiers. The first tier is the web tier, let's say 3 nodes, and we have around I don't know, another two nodes for the application tier, and we have maybe another 2 nodes also for the database. So basically each tier will be represented inside a pod, or all of them will be in one pod, or it depends on how we configure it.
Yeah, so basically, first we might split the 3 tiers into 3 namespaces. Okay. Now within each and every namespace, depending on the needs, we might split the functionality. Good. So there is not one-to-one mapping. If you go to micro with an actual microservices architecture, you need to break the middle tier or the business logic tier into multiple services. So and each and every service would be represented by a pod. Okay.
Okay.
All right. So we're going to run our first pod. Can you see my screen?
Yes.
Okay. So this is our first pod. We have the definitions. And now what I need to do is I would just say, if I do kubectl get pods. Again, we're familiar with this. I would like to see how many pods, what are the running pods that I'm having. Because it's running on a laptop, I think it's disconnected, the cluster. Let me just make sure that. Okay. Yeah, I think I have made a mistake in the cluster name of the context. If you notice, there is a missing S. When I define the context, there is a missing S here. So it's unable to connect to the cluster. There is no cluster with such a name. Anyway, okay, so I need to switch the context. Use context. Sorry, guys, I have to switch to another context. Let's switch to K8s-demo. Okay, so kubectl get pods. All right, so this is the pod that is running. And again, this is, if you notice, so this is running in the default, because here the context does not include a namespace. So if you would like to see kubectl get, first let's check what namespaces I have. Okay, so I have the NS namespace, so let's do that. Get pods minus n NS demo. So I just would like to get the pods that are working in the NS demo. So it says no resources, okay? So here in my definition, I said this needs to run in the namespace that it's called NS demo. So if you remember the command that we said we will use to apply a manifest, I would like to apply this manifest. So I would say kubectl apply -f pods demo run. Okay, so I would like to see how it goes. So I would say the same command kubectl nsdemo -w. It means basically let me watch what's happening. So see, it's already running. So now I have, it's called first pod. It's already running. If I would like to get more details about this, I would say kubectl. Now I will use describe. Okay, the pod that is called first pod. If I did not define a namespace, what will happen? It will look for a pod that is called first pod in the default namespace. It won't find it, and it will say I'm unable to locate it. See, so this is more of a more details about this pod. Where is it? This is the definition, even the history, like what are the different events? It is what is scheduled, bold. It was able to pull the image from the container registry. It's created and it started. All right. So if I would like to use to view the logs, I would say kubectl logs first pod minus n ns demo. I should have access to the logs, and this comes. The service is listening to port 30. This actually comes from the application. So the code I've written, it's written in Node.js, and it keeps sending informations to the log. So this was that the Node.js says I'm listening to port 3000, and it keeps saying the service is. Good. Are you happy with the performance of the first bot, guys? You love it? Not yet? Okay, I'll try my best to make you love Kubernetes. So I'll switch to another topic. Hopefully that will gain your attention. All right. Good. So now we just deployed one pod. You can imagine if you're going to a production kind of environment, you might have 100 different pods or 200 different pods. And it becomes very challenging to basically identify those pods and how to connect to them. And if the pod goes down, you might need to reconstruct the connectivity to the pods. And if you worked in a containerized application production, you can easily relate to what I'm saying. It's really a nightmare. Working with storage, working with connectivity and discovery. That's why Kubernetes has introduced the service discovery and the service object. All right. We know now we're orchestrating the work, so the number of pods might change. The location of the pods might change. It might be started on node number 1, then it dies. Kubernetes might decide to start it on number 2. So should I reconstruct the connectivity again? That would be a nightmare. I might add more nodes to the cluster. This is basically a very challenging work. So Kubernetes introduced the service discovery or service discovery concept through the service object. And what is basically a service object? A service object is you expose the connectivity to the bots, or actually a replica of bots through one service. And this service is usually identified with a DNS that is managed by Kubernetes. So regardless of where the different pods are deployed, and if they change with time, they will be connected to a service. And even if they change their place, they work on another node, that you only, anytime you would like to reach those pods, you only need to speak to the service, and the service will manage and it will pass your request to them. And Kubernetes, it uses its own DNS. It's a start with the service name, then the namespace, then the cluster name. You might notice that in the middle, we use SVC. SVC is the short name for service. And so far, the only component, so the only object that has an IP that has a DNS record is the service object. However, the guys who created the Kubernetes, they decided to add the SVS just in case in the future they decided to add more components. All right. So now we say that the service basically is responsible to relay the request and the connectivity to the pods, and it can do this in so many different ways. The first one would be the cluster IP, which means it would say, okay, look, if you would like to connect with any of these pods, you can only connect from the cluster, from inside the cluster, and it will assign an internal cluster IP. It might say, no, you know what? I would be listening to the nodes on the host, and if you send any traffic to a certain port, I would catch this and I will pass it to the pod that I basically work with. We have also the load balancer, and load balancer is very similar to the cluster IP. The only difference is that it will expose the service with a public IP address. And this is usually used with the cloud. If in your environment on the desktop, you define a load balancer, it will just give it a local, it will take the local host. If you do this in Azure, for example, it will automatically create an IP address and a load balancer or resource on Azure. One last also interesting way of using services, let's assume you have a SQL database or MySQL database, and you don't want this to be deployed as a container. You still would like to have this on a SQL database, but your different components needs to interact with the database. So how you're going to handle this? So with the external name, you can define a service that all different components that can interact with, and it will relay that to the external identity. So from within the cluster, it's just a service, which is I found extremely interesting. So you don't have, and this is one of the confusion we always when we speak to people about Kubernetes, they think that they have to bring everything in to Kubernetes, and that's not true. Still, you can fit in Kubernetes in a bigger picture, and you can still interact. Okay. So now what we'll try to do is that the pod that we have created, we will expose it. We will look at the service manifest, and we will try to access the service locally. All right, good. So now, sometimes Kubernetes, for some of the functionalities, it helps you basically do the work for you, rather you do all the work. So now, if I would like to go with the standard way to create an object, I need to write a manifest that has a kind of service, and I define all the required attributes. Another way to do this is I might say, you know what, I have already a pod, and all what I need is that you just expose the pod for me. Okay, so I would say kubectl expose pod. First, pod. Just expose for me the first pod, and the namespace is NS demo. Okay. And I would like you to basically for the listen to port 8080. So any traffic should come to 8080 for that service. And because I have in my container on Node.js, I'm listening to port 3000. I would say the target port is 3000. See? So now it's created. If I go and see kubectl get svc -n ns demo. See, I have a first pod. It's a cluster IB by default. This is the cluster IB address, and it listens to port 8080. Good. Now, if I would like to expose this, I would say, okay, let's see how I would like to edit this. I would say kubectl edit svc, and the name is first pod. And I have always, because I did not define a namespace in the context, to say ns demo. See, so this is the definition. It has already been created for me, all the details. If I would like to make any changes, I will create the changes here. And then when I save, it will take effect, and it will apply the changes. All right. So let's try to do one thing. I would make this load balancer. Of course, I will need to remove this. I will make it listen to port 80. What do you think will happen? Would you like to guess? Okay, let's see. Ah, I forgot to close it or to save it. Which one was this? It was this one. Okay, save, close. Ah, first pod is invalid. Okay, I won't dig into that because it's on the notepad. So let's just do that. So this is the definition. I already have it here. Okay, I will just mark this. I have marked this, and I would say just listen to port 8080. Sorry, port 80. Let's see what will happen. I would say kubectl apply -f, right? And what is the manifest name? It's called service demo go. Can you see something that is interesting? It says field is immutable. You cannot change this. Okay, what I cannot change? The port. So this is immutable. So what should I do? I should delete it, and I should create a new one. So I would say kubectl create, delete svc first pod and -n ns demo. Okay. Now it's created. Now let's see kubectl describe svc first pod. I forgot to add the namespace. Yeah, that's why I should have done the context.
Default.
Right? Demo
Yes,
Okay.
it's port 80.
Yeah, it's port 80. The target is 30, etc. See? Okay. Now, one other interesting thing I would like to see if I did kubectl get svc first pod -n and s demo. Can you see the external IP? It's what? It's bending. Previously, it was saying, no, I have no external IP because it was a cluster. Now it's trying to get me an external IP. Okay? And once it's done, because I'm running this on my machine, it will give me local host. So -w, it means that basically keeps showing me what's going on. Okay. Let's see what's happening. Maybe because I used the port 80. Yeah, it does not list any events yet. Let's wait for a bit. Hopefully it will take some time and then it will.
So Ala, basically,
Yeah.
if I have another image of my let's say Docker image, which represent a new change in the code, a new version.
Yeah.
Every time I have to delete the bots and then create them again.
Yeah, that's
There
a
is
very
no.
that's a very good question, and that will take us to the other topic, which is the deployment. Okay. So this might take some time. Let's see how, because the only thing I wanted to show you that because we used a load balancer, so it will assign an external IP address. Then from my browser, I can just type localhost and port 80. Then this service will catch it on port 80. It will forward it to the pod on port 3000, and you will get the response from the server. Maybe I think because port 80 is already taken or something. I don't want to try this again. I think we're already over time. So just the idea, we'll see it as we go. Good. I hope the service concept is clear, guys, before I move to the next topic, which is the deployment. So again, so should I be, how I'm going to deploy my pods? I'm going every time to kill them and start them, and that's a very good question. So we'll talk about the deployment. We will talk about the components of the deployment manifest. We will speak about the recreate strategy and rolling update strategy, and scaling up and down. So what is a deployment? So deployment is the way that it will enable you to simply roll out new versions without a downtime. So, and this is very important. So you have a certain version that is working and your application is running. Now you would like to deploy a newer version. You don't want any downtime. So you would say, what if you were telling me that I have to kill the pod and start a new one, so my service will be down, right? So that's exactly what the deployment will do, and it will completely orchestrate the work, and it will be managing this. It will help you move from one version to another, and it will provide you a rollout that is specifiable and careful, which means it will be staged rollout. How deployment works basically is that assume that you have deployed three replicas of your pod, and you attach all of them to one service. Okay. I just would like to go one step ahead, just to make sure that the concept is clear. If we go to the service definition, you will find here something called selector. Selector app, first app. This means that this service basically any traffic it receives, it will pass to any pod that is marked with an app, first app. If you go to the pod demo, you will find in the metadata, in the labels, it's called what? App, first app. So if I have deployed 3 demos, if I deployed this 3 different times, then I will end up having, if I change the name, of course, I will have 3 different pods, right? Now, the good thing is that the service will automatically catch the new one and it will start load balancing the work. I don't need to do anything on the service level because it works based on labels. Okay, so assuming that you have multiple pods, so this is where the deployment will help you. The deployment will come and say, you know what, I cannot bring down the 3 pods all together and create them all again. I would first kill one and replace it with the newer version. Then I will look at the liveness probe to see if it is responding. And it's live, it's reporting that it's working. Then I will move to the next one. Then I will move to the third one. In this way, you will end up basically not having all your pods dying and your system not working. It will do this gradually and gracefully, so your system will still be working. Okay? Does this? I hope this answers your question. And in the production workloads, we don't deploy pods directly. We use deployment. Sometimes we use the pods directly when you would like to do something like load testing. So you just deploy a small pod that has an image for a load testing functionality, or maybe trying to mimic some, trying to do some attacks in your environment, and then you just kill it. So you want to do that through a deployment. But for production, you need to do this with deployments. Okay. Now, what is a deployment? Yeah, please go ahead.
Ala, we have a question from Harzallah.
Sure.
Harzallah, can you just ask your question?
Thank you, Ala. So using deployment is always automatic. So it will do the deployment one by itself, not with our intervention. Right?
Exactly. And Harzallah, the nice thing is it will not only do it one by one. You can direct this, and we will see that. There is something we call the role update strategy, where you might say, you know what, don't kill any of the pods. Create a new one first. Then after it says I'm okay, then kill one. Then, or you might say, no, you know what, I have 10 pods, I'm okay to go by them 2 by 2, right? Or you might even say, you know what, regardless of the number of pods I'm having, I just want to do this grace deployment for 20%. So you can use absolute number, or you can also use a percentage. And I'll show you what are the different, and how you can define this. All right. So on the top, sorry, go ahead.
No, okay, go ahead.
Perfect. So on the top, guys, I think we're familiar with this part that says the API version, the kind, the metadata, right? We're familiar with this. Now see this. This is the specs. The specs, I would say replicas. I would like to have 3 replicas from this pod. And so create me 3 replicas. So I don't have to create three times. I need to run the manifest. I will just say, basically do this 3 times. This is the target pod. It's called, for any pod that is called first app, then I would like to have 3 replicas. Now you define the strategy. The strategy, you say, this is my max surge and max unavailable. And I quickly touch on this. The max surge, so I've said I would like to have 3 replicas. When I say the max surge is 1, so I'm telling the Kubernetes, look, you can make it 4 as you deploy, You can exceed the number by 1 as you deploy, but that's the maximum number of additional pods you can create. You create a fourth one, then you take out 1. Then you create an additional 1 to 4, then you take 1 from the old. The maximum unavailable, you would say it's the opposite. You would say, okay, you know what? At any certain point, I don't want more than 1 pod to be from the count to be not there. So you cannot just take all of them out. You cannot. You might say, okay, out of the 3, I am okay if you take 2. And what is the difference this will make, of course, is the how quick you can deploy. Because if you have 300, if you have 20 pods, you can also define, wait period between each and every round. So it might, if you define this as 5 minutes, and if for each pod to come to the live will take 2 minutes, and you have 20 pods, so you have to multiply 7 by 20, which means 140 minutes. That means more than 2 hours. So this depends on, but you have full control on that. And the good thing is once you do that, it's fully managed by the Kubernetes. You don't have to do anything. All right. Now, if you have a pod that is already there, all you need to do is to put it under the template, and now you have a complete deployment.
Ala, one.
Yeah, go ahead.
If we discovered during the deployment that the new pods is not working, let's say.
Perfect. You can pause. You can say, I would like to pause the deployment. So I have already deployed 1. I found out it's not working. I would say, okay, pause the deployment, leave the other 2. Okay. And you can later, you can fix it, then you can do resume. We will come to this. Okay. So we've discussed this. This is called the rolling update strategy. If usually we use the recreate when we work on development, and recreate will basically create kill all the pods before it creates any new pods. All right.
Ala, sorry, Ala.
Please go ahead.
Yeah, right with you. We can create pods from the previous version. For example, if you delete, if you create pods and you discover that this is not working, or you pause the deployment, okay, and you have a previous version from pods.
Correct. So you can, and that's why deployment are there. So if you deploy things with pods, with the pod manifest directly, you will not be able to roll back. If you use deployments, you can roll back to a previous deployment. Yeah. So do you see the difference? That's why I said, if you're working on a production, you need to do things with deployments. You cannot do things with basically just directly pods. So you need to have a deployment that encapsulates the pod definition. All right.
All right. Thank you.
So you can pause, you can resume, you can roll back to a previous version. All of that is possible. Okay. Perfect.
Okay, thank you.
You're welcome. We have auto scaling also that comes as part of the deployment. You just need to say, okay, auto scale this deployment based on a CPU. The minimum number of pods is 1, the max is 10. You can do this based on the CPU or based on a custom metrics. All of this is available. Of course, there are some prerequisites that required to have this in place, some kind of pod called hipster that collect information about the different pods, and that's usually not available in the desktop version of Docker Desktop. Okay? Interesting, guys? Okay. So let's deploy our first deployment. So here's the deployment demo. Okay, so here is the information, etc. Let's first look at what pods we have, right? Get pods. See, we have one first pod, right? Now let's deploy and see kubectl apply -f. It's called deployment, not Azure demo, deployment demo. Okay, let's go and watch what's happening. See, now we have 3 additional, right? But they're called deployment demo because that's the name I used. Okay. So we have the deployment demo. This is a random number, and this is random. Why? Because this is all managed by the cluster. Okay. So now I have 3. Now, if the deployment, because this is a very quick and small Docker image, sometimes it starts telling you what's happening. Like I'm pulling the image, I'm doing the first one, still the second, you see the second one, then the third one, etc. Okay. Now let's try to do an auto scaling. So I will just sorry. Okay, let's do auto scaling. So we'd say kubectl auto scale. I would like to auto scale the deployment that I call deployment demo. I will do that based on the CPU. I would like to have a minimum. Sorry, CPU. If the CPU is 50% or goes above 50%, or so 50 minus the minimum number of is 1, and the max is 10.
Currently, you specified 3, right?
So, sorry, I think. Oh, that's wrong. So that's one auto kubectl auto scale deployment demo. Minus, I think this is CPU percentage.
Yes, it should be 7%.
Yeah, the name of the deployment is wrong. What was the name of the deployment? You know what's wrong. You guys tell me. Namespace. I hate that. I have to pay the price for not defining the right context. So suffer with me. Sorry for that, guys.
Now, Ala, it will not scale up unless it will hit this criteria, which is 50% of the CPU.
Absolutely, and actually, it won't scale even if that happens, because I don't have that bot deployed that called Hipster that will look at the performance of the different bots. I just wanted to show you that how you can do this. Now, if I would like to see the manifest, again, guys, everything is a resource. So I would like to see the manifest. I would say kubectl. I can view or I can edit. I would say view get HBA horizontal bod auto scaling -n and as demo. See, I have a deployment. So this is the target, maximum, whatever. I would say kubectl edit HBA, and that is deployment -demo -n and as demo. See, so this is the definition. So you don't have to create this from scratch. You might use some of the commands that will help you to achieve this. Okay?
Yes, I just want to highlight for the admins, يعني just try to compare the normal work you are doing now without the help of Kubernetes with the traditional way. For example, your infrastructure will be under monitoring maybe system. After you will notice a huge maybe traffic, you will go and log in, start maybe increasing or scale up the I don't know, the resources, the VMs, and it will take time. You have to make sure it's no traffic is hitting. You remove the VM from the load balancer. All of this can be done automated for you using the Kubernetes. The other thing, even if you, for example, today you are having like a sale, you are managing a website for an e-commerce, and there is a sales today, so you are expecting a huge traffic. You can even put this strategy of auto scaling before the deployment or after you deploy by a seconds. So this is the biggest benefits when it comes to the administration.
Exactly. So if I would like to see the history of the deployments, see, it gives me that revision 1. If we try to do one thing, I would like to add a label, say role web. Again, I would say apply. See, it has already done this. Let's see what about the history. So you can see that still it is revision 1. And that's because there is something, an advanced topic that is called annotation. I did not touch on this. Basically, if you roll out a newer version, you need to provide an annotation that is called the change cause. You need to define this in the metadata just to give a direction that this version 2 has come because of that. This is part of the governance around building your environment. Okay? Okay, good. So we'll come to Helm and Ingress. So what is the Ingress? Ingress is basically a load balancing system in Kubernetes, and it's an HTTP based. So if you can look at a service, so far the service will basically do just load balancing. And you cannot define other than like the selector, which you can define only it should go to which bots. But you cannot define, for example, if it is /images, go to the pod, to the service that is responsible of handling images. If it's /videos, go to the service that handles videos. And to handle this in Kubernetes, we have the concept of the Ingress. It's basically an HTTP load balancing system. We have something we call Ingress and something we call Ingress controller. So the Ingress controller is the object or the resource that is responsible of handling the HTTP load balancing, while the Ingress object, where you define the rules and the paths, okay? And we keep this separate. And also this is one of the, I have to say, like, if you notice so far, everything we do in Kubernetes is that we try to have modularity and abstraction. We don't want to connect things to each other. And why? Assume in the future you're currently using one of the Ingress controllers that we're using is Nginx. Let's assume that you would like to take out the Nginx and you would like to have another controller. You don't have to touch the Ingress definition. They will start work, just to bring a new Ingress controller, deploy it. Automatically, you don't have to touch any of the Ingress's definition that you have defined for your application. Of course, there is no built-in ingress controller in Kubernetes, so you have to deploy it. And this is, of course, done for a purpose. They don't want to reinvent the wheel. There are so many good solutions out there. Just pick the right solution for yourself and use it. Of course, when you create an ingress, automatically, as you might have expected, if you install an ingress controller, an automatic service with a load balancer type is created. Why? Because the ingress controller needs to be exposed to the outward, right? And again, Kubernetes is smart to create this for you. You don't have to go after you deploy the ingress. You say, okay, then now create a service type load balancer for me. No, it will take care of that for you. And as it's depicted here, so you have a service with type load balancer. You have the ingress controller. The ingress controller will basically collect the different ingress configurations, and it will start directing the traffic to the different upstream services depending on the rules defined in the ingress manifest. So here, this is just an example. I have rules. I would say if the host is KS demo, if it's the path is /first, then send it to the service that is called first service, and put this on 8080 port. Okay. If it's the path is /second, then send it to another backend service. All right, and this is all also managed by Kubernetes. You don't have to do any of that. Now, if you worked on development, or you have, I think all of you are experienced enough to know that now we always try to find out if there is some work I can reuse rather than reinventing the wheel. And even within my different applications, I might have some reusable components. Though, and that the concept of packaging and package engines is very well known in PHP, in .NET, everywhere. So for Kubernetes, the most widely known package manager is called Helm. And basically, Helm is an open source package manager for Kubernetes. It provides you with the ability to provide, share, and build Kubernetes components that can be deployed by others. You can also basically use public charts, or you can have your own private charts. Okay. So here we'll just look at install Nginx using Helm and how to create an ingress.
What is Nginx?
Nginx is an ingress controller or a load balancer. It is what we call a reverse proxy. So it's a system that will receive the requests and will analyze the requests on your behalf. So we are telling the Nginx, and if you go to the manifest of the ingress, we say, look, Nginx, if you received anything on localhost and the path is / send this to the first pod. So Nginx is a reverse proxy or ingress controller that will basically be the first point to receive the traffic coming to you, and will direct this traffic based on the rules that you have defined for it. Okay?
Okay.
So here, if you notice, I would say Helm install Nginx demo. I did -dry run. Okay, I think it needs to be -dry run. And this means, you know what? I would like to see the impact of this change, but please don't do it. Don't install it. Just show me what will happen. So it's install Nginx unexpected argument. Why? Is it just... No, I'm missing something. Okay. Install Nginx demo Nginx stable. I tested this. Here's another name.
You may need to put Uber city.
I think it's because it's already in there is a definition says this should reside in the default namespace, and it does not allow more than one component to be there. But I used to do this, so a dry run. Just let me check the help, because if you do a dry run, it will basically just it is there. Why it's not? So it's just simulate the installation. It will not do the installation. See? So this, as if it has installed it, you know? So it will tell you, you see, it is well listening to port 80 for TCP, HTTP, listen to 443 for HTTPS. You know, this is the definition and how it was created. The Nginx controller has been created. And now, whatever you have defined here, basically in your ingress deployment, that for localhost anything goes to dash, then send it to the service called first bot. I don't think it will work for now because I messed with different services, but let's just, and I think I changed the port to 80, right?
Read it 8080, but I don't know if it...
Yeah, so see Nginx. So Nginx is saying I cannot find I cannot find the upstream service. This is because it's tried to go to 8080 while my service is deployed on 80. Okay. So if I try to do this, let's just see. I'll make this back as
cluster IP.
Cluster IP. I think I don't want to do that. Now what I need to do, I need first to do what? To delete it, because I cannot change the port. It's immutable, right? So I'll say kubectl delete svc, that is called first pod, and it's in the namespace that is called ns demo. By the way, there is another way to do the delete. If you go delete and you just type the name of the file, the manifest file, it will delete the object. So kubectl apply -f,
apply,
right? And we'll say service demo. Yeah. If it did not work, I will not try again because we're running out of time. Yeah, I think we just need to fix the routing and ensure that it's working right. But I hope you guys are getting the idea. Sorry, I'm running out of time. So I need to move faster. Okay. Yeah, so there are so many other types of resources I showed you that we can use. There is the persistent volume. I will also not touch on this a lot. You can see how to, and this is the different volumes. There is also something we call the config map. The config map is basically a key value that you can pass to your bots, so that you use the same bots in production and development, and you only pass different configuration to them. If the configuration is basically a secret, like a database connection string or something like that, Kubernetes has another object called a secret that will manage this to you. It will encrypt the value. Stateful sets. Stateful sets are different to deployments, or what we call replica sets. Replica sets is basically deployment are built on replica sets. When we said replicas equally 3, that is the replica set. A stateful set, if you noticed, when we created our pods, it gave them a random name. Now, if you would like to maintain the name for whatever reason that is, so for example, sometimes if you have a Redis cluster and you would say in the slaves, what is the, who is the master? So you would usually give the name of the master, which is the service name, and you don't want this to change. So you would always use a stateful set. Daemon set is also when you would like to make sure that for logging purposes or monitoring, you would like to have a pod almost in every single node. Whenever you have a node added, it automatically, this should start a daemon set. You will use a daemon set. And finally, for batching and the quick things, you can have the jobs. It's just a work that once it's done, it will basically stop and be killed. Okay. Sorry, I'll skip the demo because we don't have much time for AKS. That's important to touch on that. Now we have the role-based access. Also, you can define role-based access. We have 2 types of levels. You can define this on a namespace, or you can define it on the cluster. So you can give an admin access on the cluster while you give a middle tier engineer or developer access only to the namespace where the services of the middle tier are hosted. And so this is the authentication methods. We have the concept of the role and the role binding. You can define a role, say, okay, I have role X, and this role can do X, Y, and Z. Then the role binding, you would say, okay, Ala or Tariq now is role X. So and the definition for both of them is separate. And again, this is how things are in Kubernetes. So this is the role. I would say this is the role. It's called pods operator. Okay, on the pods and in the services, anyone who is binded to this role can do create, delete, get list, patch, update, and watch. Now, if I would like to give Alice access or a group called mydev access, I would do a role binding. And I would say, okay, give them access on this role that is called pods operator. This is not one important thing, guys, is that Kubernetes, this is the authorization, not the authentication. Kubernetes needs to work with an identity provider, and this is one also of the advantages of going to the cloud, because you can avail Azure Active Directory, who will provide you with the different identities, and you only need to do the authorization. So these are basically the different verbs you can define: create, delete, get list, batch, update, watch, and proxy. All right, now we go to Azure. We go to the cloud. Any questions? I wish I had more time to allocate for Azure Kubernetes services, but at least you guys now can have, if you don't have a free account, I think you can have a free account and you can start working there. So why we need Azure Kubernetes services? It will simplify the process of deploying and manage Kubernetes cluster. If you would like to do a production cluster on your on-prem, please, you will really suffer. Kubernetes is built with the idea that please host me on the cloud. I need to be there. Okay, so it will reduce the complexity. Again, it will offload most of the operational work to Azure. you don't have to handle a lot of the critical tasks. And the good thing is that Azure Kubernetes services is free. You only pay for the nodes. So as if you're just having your workloads on a VM on Azure. So and we've seen this. Some people, they might think if I go to Azure Kubernetes services, I will be charged additionally for using the service. That's not right, not correct. You only pay for the nodes, and the nodes are VMs. You define whatever VMs size you want, and you will only be charged for this. What are the different benefits? Wow, many. Identity and security management, integrated logging and monitoring, cluster node and pod scaling. You can manage this in Kubernetes, so in Azure. So if we've spoke about the bots auto scaling, but what if your nodes are not enough to handle any additional bot auto scaling? On Azure, you can define an auto scaling for the bots. You can do a cluster upgrade, which is a very daunting experience if you have this on-prem from one version to another of Kubernetes. And we know Kubernetes is changing very quickly, so many changes. Still, I would say it's still in the, the hot early days where they keep changing. The Ingress and HTTP application routing, it's automatically, you will have, whenever you deploy in Azure, you will automatically have a load balancer there. Of course, development tool integration, deployment of your code, defining a CI/CD is super. You can define a CI/CD that will deploy in Azure Kubernetes, and you have your cluster running. Honestly, I'm not in maybe 10 minutes or 15 minutes, and you will be running. And of course, it supports private container registry. And if you have any regulatory compliance, it's already out of and supported by Azure. Okay, sounds good. So we have so many to go over a demo. We need to create a cluster and attach a repository to a cluster. If you noticed, when I created a pod, I have to locally, I had to pass a secret, right? If you remember this, let me go back to the pod demo. See, I had to pass a secret. Why? Because I'm pulling something from a repository outside, which is on Azure, so I need to authenticate. Now, if you're on Azure, if you deploy, you don't have to do that, because you only say, okay, you know what, attach this to my cluster. Okay, so let's do this quickly. I would do AZ login. This is basically will login me to Azure. All right, thank you.
And you will see your subscription ID.
It just takes some time to get me the list of subscriptions. Yeah, so this is the subscriptions I have access to. Now I would say, okay, I would like to on Azure. So this is Azure CLI, guys. It's I'm just creating resources on Azure from the command line. I would say create. So I would like to create an Azure Kubernetes services. I will name it AKS -Kuwait demo. I will put it in a resource group called Kubernetes. I have already it's set up there. I would say, you know what, attach an Azure container registry called Foodie. This is something I have already created. And I would say, okay, to access this, please generate SSH. So easy create, I think that's good. It's have all the components. Yeah, so it's creating the service principal that the Kubernetes will use to access the Azure Container Registry. So this might take some time to create it. So I might switch to another terminal. Okay. And let's just see, I would say AZ AKS list -o table. I'm just saying, like, tell me what are the Azure Kubernetes services I have in Azure. So these are the different. Can you see this? It says it's creating. So it's creating this for me. Okay. Now, the nice thing, guys, is that I would like to start working on this Kubernetes cluster. So all I need to do is that just to say, okay, you know what, Azure AKS, please get me the credentials, okay, to basically to access the cluster that is named Foodie, okay, and this is as part of the resource group that is called Kubernetes. All right. What is that? Get credential. This is name. Foodie. Yeah. So merged Foodie as a current context because I have already this. Now, where's the magic, guys? If I go and say kubectl, okay, config, get contexts. Now I have it as a context. So everything, I just need to switch to the context that is on Azure, start doing everything I did with you, like the ingress, the service, the pod, the same way, nothing more, and it will be automatically deploying things to Azure. Okay? Okay, so now we are ready to deploy our first deployment on our cluster. I believe our cluster now is ready, and we can do this just the same way we did this on our local cluster. So we will use the kubectl, we will apply -f and deployment Azure demo. I have just removed the image pull secret because I have already configured this as part of creating the Azure Kubernetes service. No longer I need to pass a secret because I have already attached the Azure Container Registry to my cluster. So let's deploy. All right, it's working. Yeah, so it has been configured. If I say kubectl get me pods, see I have two pods that are currently running because in the replicas I think I defined this as 2. All right, now if I made changes, I can make changes and make this 3 because this is a deployment. I can redeploy again. And remember, deployment, it will just adjust, it will not delete. So I would say now get pods. See, I have now 3 pods that are running. As you can see, these 2, their name did not change, which means they have not been redeployed. As we just checked that we need to add 1 additional pod and it has been added. So let's switch to Azure portal and see what's happening in our cluster. I will start with monitoring. Monitoring is under insights. One thing to keep in mind that your cluster will not be monitored automatically. So you have to enable this. If you go to Azure monitoring under containers, you will have monitored clustered and unmonitored clustered. This cluster I have already configured previously and it is already monitored. I have no unmonitored clusters, and you can see what is the status. It's healthy. Let's go back to my cluster insights. Here I have informations about the cluster overall, node CPU usage, how many nodes are ready, how many nodes are waiting. Here how many pods are running. As you can see, I have 15 pods running or active. That's while I have only deployed 3. That's because Kubernetes services, actually all the work that is happening and the management is done through also functionalities or containers. So the system itself will deploy different pods to do its functionality. Here we can check the nodes and what are the pods that are running for each and every node. I can see the logs for that node, and it will provide me information about what's happening on that node. So you can see I have new containers created. Here are the details of the cluster. Controllers, we did not touch on controllers. This is an advanced topic. We just highlighted this in the introduction. Now here are the different containers you're having. As I said, you will see many containers that are deployed by the system. We deployed this container that was called thirst pod. We can always view the logs, and here, because the logs, this is coming from the Node.js application that is hosted inside that container. Okay, these are the different events that are related to this container, and these are part of when you do the describe command from the kubectl. All right. Of course, you can filter, you can slice and dice the data, and that is all you can do. You can do many things here. Okay, great. So let's go quickly over the menu. Here in the access control, you can assign access on the cluster level and on the service level. If you would like to assign RBAC, role-based access, on the namespace level, this needs to be done. It's not available now from the portal. You need to do this through the PowerShell or Azure CLI. If Azure Security Center has any recommendations for you from security perspective, you will find it here. Our cluster is very healthy from security perspective. If we go to the node pools, we will see that we have only one pool of machines. The node count is 1. I can decide to scale up or scale down. Currently I'm saying no, don't scale up, just keep it on 1. I can do auto scaling, change the count depending on the load. I will keep this as 1 so that the costs don't go up. I'm using a trial account. Okay, your answer is discarded. Okay, discard that. Upgrade, you can change the version, update the version of Kubernetes without getting into the hassle of, and this will be all managed by Azure. Network will give you network information. Dev spaces is about if you've heard the news that now Visual Studio is available also online. So you can create development spaces, you can write your own code, and all of that is not locally written on your machine. It's actually on the cloud. Then you can run or deploy or do the kubectl and all these commands rather than doing them from your local machine, but through Visual Studio that is already hosted on the cloud. Deployment center, you can connect your cluster with any of these sources and configure the deployment. Policies, they are just as any other Azure policies. They are currently in a preview. they will help you tighten the security and monitoring and management of Azure Kubernetes cluster, and they will save you a lot of time of the things that you need to do manual. This will give you better governance over your cluster. This is still in a preview, so you have to opt in before you start using these different policies. But still you can use them from Azure policies, and you can apply them on your production workloads. Insights we covered. You can assign alerts, and of course the different metrics and logs you can see. So long story short, there are so many functionalities in Azure Kubernetes services. It helps you to have a quick start on Azure Kubernetes, on Kubernetes. You deploy your first cluster very quickly without worrying about laying out the infrastructure, configuring the infrastructure, the nodes, the connectivity, all of that. In addition, it supports, adding storage. Can be very easily. You don't have to do much. You can just reference Azure storage accounts or storage disks, and they will be available to your cluster. You don't need to configure this. So you're able to do a lot. You're able to go to production in a very short time. Perfect. I think, guys, we have reached the end of this session. So we highly appreciate. I hope you found this beneficial, and it gives you some insights about how Kubernetes works. And one last word, guys. Kubernetes, you hear a lot about it. You hear that everyone is talking about it. And once we hear a lot about something, we think it might be out of reach or extremely hard. I honestly found it very easy, very nice to work with, at least when you ramp up your knowledge. And the real experience you will get when you start hitting the production environments, and you will really enjoy your journey. That's it from my side. We appreciate that you scan the code and send us your feedback, whether positive or negative. We would like to hear from you, and hopefully we can improve our next sessions. Thank you, and I hand it over back to you, Tariq.
Thank you, Ala.
Thank you, Ala. Very informative. And as I want to encourage you also, guys, to scan the code, give us, your feedback. As I said many times, this session and the one previous was based on your request. So that's why your feedback is very important. We want to hear from you and provide whatever is needed. So thank you. I would like to thank also Ala one more time for your time and the efforts. And thank you also the people in Microsoft to make this session available. That's it. I think if anyone has anything to ask, maybe we'll have 5 minutes because we are already, passing 9. Yeah. So anyone has any question wants to ask? Okay, I think we don't have. So that's it. Thank you very much for your time. Till the next month. We hope you will be safe and see you again, inshallah, next month. Assalamu alaikum.
Assalamu alaikum. Bye-bye.
Thank you, everyone. Thank you, Tariq.
Thank you, Tariq. Thank you, Ala.
Thank you.
Thank you all.
Thank you, everybody.